Argon Argon dating by O'Ray and Michael. Argon Argon dating is a radiometric dating method invented to supersede potassium argon dating in accuracy. An isotope is each of two or more forms of the same element that contain equal numbers of protons, but different numbers of neutrons in their nuclei, and hence differ in relative atomic mass, but not in chemical properties, in particular a radioactive form of an element. People think of radiometric dating by analog to sand grains in an hourglass. When the sand falls, there is the rate, so that means there must be a ratio of grains between top and bottom, and they are always going to be corresponding in size to the time elapsed. The RR method is a method that is used to study volcanic elements like lava. What is a radioactive element? Only the elements with an atomic number greater than 83 are radioactive. Naturally occurring radioactive elements include radium, thorium, and uranium. Several radioactive elements are not found in nature, but have been produced by the bombardment of stable elements with subatomic particles in the cryotron.
Now a video on the topic of radiometric dating.
Keep in mind that there's all kinds of scientific jargon on this topic, and so we'll just present a very straightforward, simplified version of the process. Radiometric dating is the process of estimating the ages of rocks based on the decay of radioactive elements in them. Basically, there are certain kinds of atoms in nature that are unstable and spontaneously decay into other kinds of atoms. For instance, uranium will radioactively decay through a series of steps until it becomes the stable element called lead. The original element is called the parent element, and the end result is called the daughter element. Radioisotope dating is commonly used to date igneous rocks, rocks which formed when hot molten material cooled and solidified. The dating clock started when the rock cooled. During the molten state, it is assumed that the intense heat forced any gaseous daughter elements to escape. It is assumed that once the rock cooled, no more atoms escaped, and any daughter element now found in the rock is a result of radioactive decay since that rock formed. The decay rate is measured in terms of half-life, that is, the length of time it takes half of the remaining atoms of a radioactive parent element to decay. Now, of course, that can be measured in a laboratory, and it is assumed that since we know the decay rate, we can calculate backwards and come up with the age of the rock.